Hello everyone, hoping you're having a nice Monday evening. Tonight we're going to be talking about the base angle theorem, so we'll go ahead and jump right in. Alright, so to talk about some notation and some vocabulary so we can talk about this, we have this triangle here up in the left hand corner, and we're going to say that this side here, we're going to refer to that as a leg, and this side here will be another leg, this side will be our base, and these guys here will be our base angles. So base angles are formed by one leg and the base of a triangle. Same thing for the other one leg and a base. This angle up here we're going to refer to as our vertex angle. So that brings us to our learning target for tonight, which is the base angle theorem, which says if two sides of a triangle are congruent, then the angles opposite them are congruent. So if we draw another triangle down here that's a little bit bigger, I'm going to draw this triangle here. Yep. And we're going to say that two sides of a triangle are congruent. Then we know that the angles opposite them are congruent. So if we look at this side here, this leg, this angle is opposite. And then if we look at this leg, we have this angle is opposite. And because we know that these two are congruent, we then know that these two angles are congruent. And the converse goes the other way. So if we have the two angles, then we would know that the opposite sides of those angles are also congruent, or our two legs would be congruent. So if we're given the base angles, we can say that the legs are congruent. If we're given that the two legs are congruent, we can say that the base angles are congruent. Okay, so now let's look and see why that works. Let's prove it. Alright, so we're given that, let's go to yellow. So we're given that JK here is congruent to JL right here. And then I have this written in red here that KM is congruent to ML. And we technically drew in this line right here. And we can draw that in so that it bisects angle KJL. And that would create a midpoint. So we're just going to go ahead and include that in our givens. Technically that is by construction, but again we're going to go ahead and include it. So let's get into our proof here. So let's write in our first given that JK is congruent to JL, and we know that because it is given. Yep, there we go. Alright, and we also know that Km is congruent to ML. And that also is given. Alright, so at this point, what does it look like we're going to use to prove that these two triangles, JKM and JLM, are congruent? Because we know that we're going to have to prove they're congruent before we can use CPCTC, which stands for, and you should have automatically just said that corresponding parts of congruent triangles are congruent. But in order to use that, again, we have to prove that the two triangles are congruent. Well, we've been given two sides. What can we say about this side right here? Oh, well, then we can say that JM is congruent to JM by the reflexive property. And then we have a side. We have a side, we have a side. So then we can say that triangle, try and squeeze this in, JKM is congruent to triangle, and this is important to note our congruency statement here. So J, and then we want to have L, because JL is congruent to JK, so those need to match up. So we have JLM. And we know that by side, side, side. Now we can go one step further. Now that we have that these two triangles are congruent, so if we know that all of their sides are congruent, we also must know that their angles are congruent. So then we can say that angle K is congruent to angle L by CPCTC. Corresponding parts of congruent triangles are congruent. So we just proved that given two legs of a triangle are congruent, then we know that the two base angles are congruent. So we just proved our base angle theorem. Alright, so now let's look at a couple of examples putting that into use. So let's look at this number 15. This is in your book. So if we look at number 15, we automatically know that the sum of the interior angles of a triangle have to equal 180 degrees, right? We also know that since our two legs are congruent, the opposite angles of those legs, so our base angles, are congruent. So that means that x equals y. So we would have 2x, right, because we're just going to substitute y because those two are equal. 2x plus 102 degrees is going to be equal to 180 degrees. And so then from there, we just use some algebra. We say 2x is equal to 78 degrees. And then if we divide that by 2, we get x is equal to 39 degrees. Right? So we looked and said we know that x is equal to y, so we rewrote as just 2x. You could have said 2y, that would have worked too. But because we know that the two legs are congruent, the two base angles have to be congruent, they all add up to 180 degrees. So from there we just solved for x and found that x was equal to 39 degrees. And if x is equal to 39 degrees, then y is also equal to 39 degrees. Alright, so looking at 17. 17 is a little bit trickier. But let's start out with what we know right away. Well, we know that x plus 9y plus 90, right, because we have a 90 degree angle here, is equal to 180. We also know that, again, because we have two congruent sides, the angles opposite are congruent. So if that means this angle is congruent to this angle, we can say that x is equal to 9y. So now we have a little bit of a system, but it won't be too bad. So let's change colors here and make it blue. So then we can say that we're going to substitute this 9y in for x and say that 9y plus 9y equals, and then I'm just going to subtract 90 from up here. Say that that's equal to 90 degrees. So then we would have 18y is equal to 90, and y is equal to 5. Now we can go back in and take this y equals 5, and now go back and solve for x. So we know that x is equal to 9 times y, or 9 times 5. So we know that x is equal to 45. Alright, and then there are two final answers. So now the question that I want to leave you with is, if we know all sides of a triangle are congruent, like this one right here, if we know that all the sides are congruent, can we say anything about the angles and why? So keep in mind what we just learned about in our base angle theorem, and see if you can have an answer ready to go for class tomorrow. Alright, thanks for watching. Have a good night.